I'm making this short video for you for your lab today, which is on plate tectonics. And um, what you want to do for the Plate Tectonics Lab is go to your lab manual and look at pages 246 to 253. And I'm going to give you a few hints to get started. You're going to need a pair of scissors to do this lab, by the way. And first thing I'd like to mention is on page 246, it shows you a picture of the continental shelf. And what I wanted to show you in this video, what the continental shelf is. You can see that here you've got continental crust, here you've got oceanic crust. Well, the continental shelf is the shallowest part of the ocean. Even though it's underneath sea level, it's underneath the ocean, it's part of the continents. That's the first hint that I have to give you in this. The second hint I have to give you is on page 247. You're going to need to cut out, take a good close look there and compare that with page 249. Page 249, you're going to need to cut out the continents, see if the rock types match, and there's 5 different rock types there, and put the continents together and see if you get a better fit with including the continental shelf, as Wegener suggested, not including the continental shelf, as Wegener suggested, or including the continental shelf, as Bullard suggested. On page 248, there's a chart there that shows you the results of the deep sea drilling project on the mid-ocean ridge, the Atlantic ridge. On the y-axis, you have age going from 0 to 80 million years. And on the x-axis, you have distance from the mid-Atlantic ridge going from 0 kilometers to more than 1,600 kilometers. And what they want you to do is figure out how fast is the sea floor moving away from the mid-Atlantic ridge, because the mid-Atlantic ridge is a mountain system that goes through the middle of the Atlantic Ocean. And the plates are moving away from the mid-Atlantic ridge like 2 conveyor belts moving away from the mid-Atlantic ridge. The question is, how fast are they moving away from the mid-Atlantic ridge? First thing you need to do is use that diagram on page 248, convert kilometers into centimeters, and then divide that by millions of years to get your answer in centimeters per year. Then you want to compare that to what you get on page 247. On page 247, they ask you how fast is South Atlantic moving according to the numbers there in figure 6.3. So figure 6.3, they show you that the distance between Africa and South America is 4,828 kilometers. Convert that into centimeters, and then that occurred over 120 million years. Divide. See if you get a different number using the chart on page 248 versus the numbers you have on page 247. Read a little bit about seafloor spreading, and that'll help you as well. On page 253, there's a table that you need to fill out. And they give you the age of 8 different Hawaiian islands. The Big Island of Hawaii, Maui, Molokai, Oahu, all the way to Midway Island. They show you the age of the rocks and the distance from Kilauea, which is a volcano on the Big Island of Hawaii. Then you need to figure out how fast are these islands moving in centimeters per year. How fast are they moving? The islands are moving because of a hot spot underneath the Hawaiian Islands. And I'm going to send you 2 videos to show you, so you know more about how hot spots work and how the Mid-Atlantic Ridge works. But they gave you the answer for the island of Maui. Maui is 221 kilometers from the big island of Hawaii. And the age of the rocks is 1.3 million years. How did they get that answer of 17 centimeters per year? Well, first they converted 221 kilometers into centimeters, and then they divided that by 1.3 million years. They got a rate of movement of 17 centimeters per year. You want to fill it in for all of the other islands, and then you want to get an average. Then you get the average of those 8 islands. Then you can answer the questions on page 253, where it says when was the rate of plate movement most rapid, when was the rate of plate movement slowest, how does the overall rate of movement of the plate compare with the rate of the South American and African plates. Then you compare that to the number you got at the beginning, where you were looking at page 247. So, for the big island of Hawaii is right over the hot spot, so that should make sense to you if you think about it. What would the rate of movement be for the big island of Hawaii, do you think? Well, what's 0 divided by 0? 0. So try and figure that out. I'll send you 2 videos to look at. And if you have any questions on this lab, just send me a remind message, or if you prefer, send me an email. Okay, I hope you have a great day.